Hello, calculus fans. Okay, so we're going to evaluate these limits. Limit as x goes to 0 of sine of 4x over x, and limit as x goes to 0 of sine of 3x over sine of 5x. What we're going to do when evaluating these limits is make liberal use of this thing. Limit as x goes to 0 of sine x over x equals 1. So remember that this was the limit that we used when we computed the derivative of sine of x. We didn't actually prove that this limit is 1. We deferred this by saying that the book has a geometric argument for it that you can go look at. Also, we said that you could just try to plug in some small values of x and convince yourself that this is true. All right, so here's the trick. What we're going to do is multiply the top and the bottom by 4, and that way what we see on the inside of the sign matches with what's in the bottom. And what I'd like to do now is make a change of variables. That is what you see on the inside. I'm going to let that be a new variable. So let's call t that new variable. So we'll let t be equal to 4x. And so now we'll get a limit of 4 sine t over t. We can pull that 4 out in front. And now we should be able to see that this limit is the same as this guy. It's a different variable, but it's the same limit. And that limit is equal to 1, so our answer is going to be 4. So now let's take a look at the other limit. Okay, so this one has a trick also. Let's divide the top and the bottom by x so that we can make limits kind of like what we've been dealing with. And then we'll do the same kind of trick that we had for the other one. We'll take the numerator and multiply by 3 over 3, and then we take the denominator and multiply by 5 over 5. Okay, so now we're going to use one of our limit laws that says that we can run a limit into both the numerator and the denominator. This is, of course, assuming that the limit of the denominator actually exists. Now we'll pull the 3 and the 5 out. And so now this limit is just like the one we dealt with above. You could make a change of variable to see that this limit is going to equal 1. And that gives us our final answer of 3/5. Okay, that's all for now.